Hi, class. This is Mr. Hart. In this podcast, I want to go over some of the things we covered in week two of the periodic table and chemical bonds. So, one of the things we did is we made some flashcards to help us memorize the first 10 elements of the periodic table. I think these elements are really important to know because they come up a lot in other science classes, especially chemistry. So, being able to recognize the symbols and the names of those elements is something I think that everyone should know. So, make sure you have those first 10 elements down and make sure you practice those. Also, if you're making this or watching this video to make up participation, please answer this question. How many protons, neutrons, and electrons does nitrogen have? Okay, you can use your periodic table to figure this out, but see if you can remember how to find the number of protons, the number of neutrons, and the number of electrons. Okay. Also, if you're making this up for participation, try this one. Okay, an atom has an atomic mass of 28, an atomic number of 15. How many protons does it have? How many neutrons does it have? How many electrons does it have? What is the element's name? And how many valence electrons does it have? So you'll need to use your periodic table, you need to use some of the principles you learned, and you'll need to be able to draw the shell diagram. Okay, so try that out and see if you can answer it. Okay, so let's move on. One thing I want you to, again to also remember is make sure you remember those five sections of the periodic table. Okay, so the alkaline metals in the first column, the alkaline earth metals in the second column, the transition metals, the halogens, and the noble gases. Okay, so make sure you know where those are on the periodic table and you have those memorized as well. Okay. So one of the things we did this week is we learned a couple of new words. Okay. Two of those new words are isotope and ion. So we use these words to help us distinguish between different types of atoms. Okay. So one way to think about an isotope is it's an atom with a different number of neutrons than normal. Okay. So any type of atom is going to have a certain number of protons, certain number of neutrons, certain number of electrons. Okay. Some atoms will have variations in how many neutrons they have. So think about, for example, hydrogen. Okay, hydrogen has a couple of different isotopes, meaning different numbers of neutrons. So one possible setup is hydrogen could have one proton and one electron, right? This is what we usually think of hydrogen. But it also can have one neutron, okay, which we call deuterium, or it can have two neutrons, which we call tritium. Okay, and so it can have 0, 1, or 2 neutrons. These are all different configurations of the atom or different isotopes of hydrogen. Okay, so if you look at your periodic table, you know how you have the average atomic mass? That's because atoms can have different numbers of neutrons. So they can have an average number, and then the average is going to be the closest to the number that's most common. So if you look at the atomic mass of hydrogen, you'll notice it's closest to 1. Okay? So most hydrogen atoms only have a proton, no neutrons. Okay, but that doesn't mean it can't have one neutron or two neutrons. Okay, so these are all different isotopes. Okay, so every element can have isotopes or different number of neutrons in that atom. Okay, another word is an ion. Okay, an ion is an atom with a different number of electrons than normal. Okay, so if you remember, any atom's usually going to have the same number of protons. So if I have 19 protons, I'm going to have 19 electrons. If I have 14 protons, I'm going to have 14 electrons. Okay, so if I have a different number than I should, the particle is going to have a different number. Okay, it's going to become an ion, and it's going to make the particle charged. Because if you think about it, usually you have 19 protons, 19 electrons. That'd be like 19 positive, 19 negative. Those will cancel out. Okay, so it's not charged. But if I only have 19 protons and 20 electrons, then I would have a extra negative charge, which will make the particle or make the atom charged. Okay, so for example, if you think of sodium, it has 11 electrons, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, this is the shell. sometimes sodium likes to lose that last electron, okay? And so it loses that electron, it becomes an ion, a sodium ion, and it becomes positively charged, okay? And so whenever we have this different number of electrons, either more or less, okay, that's called an ion. Okay, so make sure you have those two words down, okay? And we will get to those a little bit later and why they're so important to some very fundamental ideas in chemistry, okay? Then the next activity you did was called periodic cousins. Look that up on the website if you didn't have a chance to do it, okay? And then we just watched some videos about some of the different elements and some of their properties, okay? So we watched a video about hydrogen, okay? Hydrogen's very explosive, very reactive, because it only has, because it's such a simple atom, a proton and an electron, it can react with a lot of things, okay? Very explosive. There's also helium. We watched a video on helium, which is very unreactive because it's a noble gas. It doesn't like to react with anything. You can't light it. It's not flammable. Okay, we watched a video on nitrogen, which is in the air, but it's also very useful when it's in its liquid form because it's very cool, very cold. Then I watched a video about some other cool liquid nitrogen demonstrations. Okay, then we watched a video about potassium. Okay, and this one was just a cool demonstration about the alkali metals and how they're very reactive with water. Okay, then we did a vocabulary review. Okay, so if you didn't do that, go on the website and you can print that out and do that. It just covers the topics we covered in the periodic table, some of the vocabulary terms. Okay, all right, then we moved on to the next chapter and we got to chemical bonding. Okay, so we talked about what is a chemical bond, and a chemical bond is usually just a way for atoms to become more like the noble gases. Okay, if you think about the noble gases, they're very stable, very unreactive. Okay, and these other elements want to become like the noble gases. They want to have the same number of electrons as the noble gases. They want to have the same number of valence electrons. Okay, and they want to be stable like the noble gases are. So what they'll do is the elements will kind of trade and give electrons to each other in order to become like noble gases. Okay, so let's look at some vocabulary. Okay, so a chemical bond is a connection between two atoms that comes from giving or sharing electrons. Okay, and we'll get into detail on this a lot more later in the chapter, but this is the basic idea: is that two or more atoms will try and share electrons so that they can make a chemical bond that will make them more like a noble gas. Okay, a molecule is that combination, right? Once they're chemically bonded, you have that group of atoms chemically bonded together. That's a molecule. And then if you have a bunch of molecules that are the same together, that substance is called a compound. Okay, or a compound is a substance that is made of molecules. So, chemical bond, molecule, compound. We'll get into these more in detail later. You should kind of remember molecule and compound from the last unit. Okay, but we will get into detail in this chapter. Okay, so again, a molecule is not just a single atom. We've been mostly dealing with elements, okay, and the periodic table of elements, right? But molecule is a combination of these different elements. So this is just a 3D model, you could say, very simple model, where each one of the different color spheres is a different type of atom or element, and the lines between them are the chemical bonds. So you notice molecules will usually have very strange shapes, okay? And we started an activity in class about what molecules actually look like, okay? And you'll notice they're not usually very nicely shaped. They're not spherical. They're not nice and symmetric. A lot of times they're very sporadic. Okay, so we did an activity in class about how or what molecules would look like. Okay, so that will be uploaded on the site, and you can work on that if you missed it. Okay, but the goal from that is to see that molecules don't always form in such a nice way. You can get very strange shapes from these molecules. Okay, then the last idea we talked about is why do bonds form. And again, it's because they want this configuration of a noble gas. Here's an example of a simple atom or a simple compound of water. Most people know about water. It's H2O, right? 2 hydrogens and 1 oxygen. If we look at the valence electrons on hydrogen and the valence electrons on oxygen, hydrogen has 1 and oxygen has 6, right? From the electron shell diagrams, we know that's how many it has. So if you notice, if oxygen wants to become like a noble gas, it needs to have 8 valence electrons. It needs to have that full outer shell. So it's going to combine with these 2 hydrogen, and they're going to share their electrons with the oxygen atom. So now we have 1, 2, 3, 4, 5, 6, 7, 8. Okay? Oxygen now has 8 valence electrons, and it's stable. It's like a noble gas. Okay? So that's why these bonds form, because this is the key idea. All atoms will form bonds that will help them get a full outer shell of electrons. Okay? So this is really important too, because if you think about it, remember how we talked about the halogens being very reactive gases? That's because they have 7 valence electrons. So they only need 1 more electrons to be like the noble gases. So they'll be very reactive. They'll react with anything that will give them the chemical bond to give them that 8 valence electrons. Okay? And that is all we covered in this week. It was a little bit of a short week because of fall break, but hopefully that makes sense. And let me know if you have any questions, and thank you for watching.